Oh, hello, hello. Right on. Good afternoon, ladies and gentlemen. My name is Henry Tremblay, and I'm the General Manager for Kongsberg Maritime Simulation out of North America. I don't know if you realize it or not, but I'm the only thing standing between you and the cocktail party. Carl tells me, because I'm the last speaker, I can't use any graphs. And I'm not a hydrodynamist. So, with no further ado, I'm going to roll this forward. I don't know how much knowledge you have about Kongsberg, but I'll keep it really simple. 2 divisions, a defense and an aerospace group. That means that with 7,000 employees, you kind of, end up sticking your finger in a number of pies with some common interests. On the simulation side, for the maritime side, we work with commercial off-the-shelf stuff, but on the defense side, we have a number of folks here that are participating at this event that are here from the defense side as well as the real equipment side, but I'm going to move on with that, give you some idea of what the footprint is. Half the world defense, half the world maritime. As I mentioned, I come from the North American operation out of Mystic, Connecticut, and out of St. John's, Newfoundland, which is a place where a fair amount of the Canadian government's money goes in studying various aspects of some of the discussions you're having here today on the hydrodynamic side and the offshore side. There's also Lou Boyd. I don't know, is Lou around here? I don't know if he's here. There he is in the corner over there. He's with our Kongsberg Integrated Tactical Systems Group out of Virginia. On the defense side, we got Tony Moretta. I don't know if you're in here. She's our area sales manager. She's probably out at the booth, who works on the simulation side with me. And then there's Mark McLeod. I don't know if he made it in here. He's probably there. He is over there. He's our sales executive for the U.S. government out of Mystic. And then there's Jon Askland. Is he there? There's our man there who's he's with Kongsberg Defense Systems and deals with the integration of technology on these small craft. What am I going to talk to you about? I'm going to get you out of here in 15 minutes. We're a commercial merchant marine outfit. We cover a number of simulators. We have some 300 ship handling simulators delivered to probably some 40 countries, 50 countries around the world. But we've been in this racket since 1972. Our focus is really a regulatory training. So we meet, STCW convention type requirements for competency. But over the years, we found ourselves as an attractive alternative for some of the navies around the world. So in 1996, we started delivering the first of these blue water simulators to the navies under the current platform. And so larger ships, frigates, various other, oilers, things of that nature. And we moved forward from 1996 and captured a reasonable swath of the navies around the world. But then that brings us to today's topics, which is these RHIBs. Navies don't like to spend like whacks of money if they can avoid it. And these days, with budgets the way they are, they're even more reluctant to spend that kind of money. Oh, and there's Tony Moretta right there, sitting there very relaxed over here. I just spotted her. So at the end of the day, we decided, well, there seemed to be some pressure coming on us from various fronts, from our customers, of course, the Navy customers, asking us, what can you do to accommodate training using these types of vessels? So it's interesting because I had the U.S. Navy up there a while ago. We received a contract from the U.S. Navy back in 2000. Whoops. Back in 2000, I think it was 2004, it was something called the NSST. It's the Navigation, Seamanship, and Ship Handling Trainer. The U.S. Navy has been very good to us. They bought a commercial product. We did 27 classes of their vessels, some 30 databases around the world. We've delivered, I don't know, 85 shipborne simulators that they run aboard those ships, and some 7 shore-based facilities. But they had an interesting problem. They called us up one day and they said, We're having a specific issue in launching and recovering RHIBs. What can you do to help us with this issue? And this actually, believe it or not, was the very first piece of kit that we did, which was they wanted to be able to teach at least some basic skills on attaching these vessels once they came alongside, and to get some sense of the operational envelope and try to communicate that to the RHIB drivers and also to those that were aboard the ship who were actually recovering them and launching them. So this was an instructor facility, but we actually then attached it to a real own ship model, and that was the beginning of that process. So it was, something fairly simple. What's the procedure? How do you attach the lines? How do you communicate? With the resources that are going to either haul you up or put you down on the right. Okay, and then off you go. So what do? We take the RHIB trainer and we say, all right, we check around. It's not just the US Navy that's having this problem. It's the Canadians, the Norwegians. Everybody seems to be in the game. So we decide then, here's our issue. We see the very first thing, support from the US Navy to help us develop something for this, but then it gets a little bit more involved than that. The idea was originally we delivered the first, and remember they wanted to use the same platform, so they didn't want a whole new architecture to do this, but rather to see if we could work with an existing platform and expand its application. So at the end of the day then, we end up using our Polaris platform, which we had out there. We start then developing math models to actually replicate that. So we start off with a couple of RHIBs. One was a 7-meter. But the thing is, you got to remember with math models, we do a really good job with that. That's our strength. Our strength is the hydrodynamics and the math behind it. But it's kind of, we can only be as good as the data we get. So the original one had very basic data, and we did a 7-meter one, which is the one that you see out there. That's a 7-meter that we're running with an inboard. I think it's 250 horsepower turbocharged diesel. But it was very basic data. The Navy came back and said, hey, that's pretty cool. It works quite well. But what we want is we want to do a larger RHIB. So we did then an 11-meter RHIB. And what's interesting is that 11-meter RHIB, they didn't have much data for it. So they actually put a data package on there, a sensor package, and went out and then did some of the basic maneuvers that we need to be more effective in doing the math for this. So I find, what you're presenting really quite interesting because you're right next door. So you see how valuable these network things are. So what we needed was really good data. And we had quite good data, and they were very happy, I think, with the 11-meter and its behavior. So, but it's a bucket control, so it was a bit more involved. But we involved in the manufacturer, which was a very smart thing to do. And they actually went and ran the 11-meter on the simulator and gave it the good housekeeping seal of approval. So since then, we've actually then looked at it and said, okay, how do you make this more valuable to the client? One is the quality of the math. So what we'd done is we were moving into a new generation of, hull displacement 3D modeling. And it actually opened up some avenues for us where it made it a little easier for us to work with this. And we started then to develop, did we skip by that? No, okay. Then we started to take a look at, these planing hull and the realism that was involved in that. And what we found, of course, is that these types of hulls with, some very shallow operational, hulls, they're actually, 20 inches or less in the water. So we're actually then dealing with surface values for these waves. And our guys work pretty hard here at developing that. I'm just going to try to go back. I thought there was another, slide. No. Okay. Just take me back one slide here. Yeah, okay, right, yeah. No, that was it. No, okay, I'll just move on. So we then get some feedback on the tuning, and then we're told, the value in this is the motion. If you can't give us motion, then the static stuff is good, which they were using, of course, at Coronado and in Little Creek, so that worked out okay. But they then were told, no, it has to be motion. Well, we've had lots of experience with motion, and it's kind of interesting. That big simulator out there is in St. John's at the university, and 20% of their research actually is human factors. How well designed is the MMI? How well designed is the man-machine interface? Is it a mouse? Is it a keyboard? Can you operate that in 3-meter seas? Yes, no, how effectively? And that's a big old bridge. That's 5 meters across, and as you can tell, she's one big heavyweight. And it was interesting because we bought this from CAE. Anybody who knows CAE, Montreal? No, they make probably about 85 or 90% of the flight simulators in the world. And that there is a platform from a Boeing 747-400 underneath there. And it's one big beast. It stands about 2.3 meters tall. So it's big, hydraulic machine, and it covers the full range of motion and the rest of it. And I remember when I went there and they said, before I signed the contract, they said to me, hey, they said, where do they sit? I said, they don't sit. They walk back and forth across the bridge. And they said, well, you can't have the platform because our insurance won't cover you. Anyways, so we put some stops in the software so it could never, during its normal operation, create the Gs that you would find in that. So we've been working though with the smaller platform. That's been quite positive. We have it over there. And you got to look at this. If you're looking at buying a trainer, be mindful. Trainers have different applications. In the world today, just about every vendor will tell you it goes from a laptop to a full mission. The key is to figure out what do you want to train and how do you want to do this and what's the most appropriate thing. So something important to look at, whether motion is required or not. We think it is in some instances, but you got to be specific about what you're looking for. Again, RHIB simulability, this is our view of the world. We're trying to learn from you guys. We're looking at this and talking to the navies. How are you going to use it? Where's the value in it? So it's kind of a moving target. All we know is you can get really good math. You can do all kinds of stuff with it. So it's a question of being able, was that my bell? No, okay. That was someone's cell. That must have been the cocktail people saying they're running out of beer. So then what do we do? Where do we go with this going forward? One of the things that we're looking at, of course, is from the tactical side, the terrorism trainer. We're working with some kind of significant others in the US, which we can't talk about. But anyways, bottom line is we've been running some of these scenarios. And of course, the technology improves over time and the rest. We've made some inroads, for example, stern door marriages, things of that nature with these RHIBs. We're seeing demand for that. We've just released that capability to the Australian Navy. Boarding and inspections, we see that as happening. And, what drives this is the math. We can create the environment, the rain, the weather, the waves, the floodlights, spotlights, thunder flashes. So you can create a synthetic environment for this stuff. And so that's not lacking. But there's no rocket science. We're just chasing the gaming industry around here. So you can see, I don't know whether that shows up very good there, but we're using these light maps and the rest of it. So if you want to do night operations and things of that nature. So now you've got the element of learning how to drive this in a safe fashion, but also doing it under conditions that, may not always be convenient, in finding the range of conditions. And we think that we don't quite know how it'll roll out because we haven't sold one with a motion base yet. That's why I'm here. Yeah, we have a show special, 2,300 pounds. I'm not sure we're going to be able to take it out of here, but it's. But we think that there is opportunity there, and we think that if we put a solid model with solid data behind it, that these things are very effective. The discount. 300 pounds. No, it was 2,300 pounds. We could talk. Yeah, it's the weight. It's more like the pile of money sitting next to Buddy here. Anyways, what to do with them? You know, our view of the world is, you know, that there are some issues, but we know that on the operational side, these boats are fun to drive. And boy, I think we got an uphill battle because, you know, you're going to have to, I got to convince your boss that he's burning too much fuel, right? And you're going to tell him the only way to learn is to go out there and drive that boat. And I don't know, maybe somewhere in between there's hope. So, you know, and there's also a flexibility that generally we could work with, which is on the envelope or on the outside of it that, you know, may offer some value from a training side, I guess similar to what they do with aircraft simulators. We think that the quality of what we can do allows you to do that, and we know it works. It certainly works with the hull displacement models that we've got out there, like the Schold and all of these very kind of heavy-duty ships that we actually model and are used as a critical linchpin in, you know, in the certainly in the blue water side for the navies. And again, this issue, personal safety factors and the rest of it. So, but I'm sure I'm kind of preaching to the choir. And there goes that famous 17 minutes.